Can you guys hear me? Oh, there we go. You can definitely hear me now. So thank you guys for coming out today. How's build going for you guys so far? Pretty good? Pretty good? Have you guys been to any other container discussions? Yeah. So how many of you guys, when they asked me to do the talk, they were kind of on the fence about what level of technical nature we should be in here. And we kind of landed on somewhere between a 200 and 300 level demo. And typically what that means is that we will definitely do some sort of leveling of the playing field for folks, but we won't shy away from code. And in fact, I had quite a bit of interesting stuff to show you before the demo gods kicked in this afternoon. But I think we should still have quite a bit to talk about, and we actually might have a little more improv time than we originally scheduled. So just curious, how many of you guys, obviously if you're here, you've probably heard of Docker. How many folks here are actually running Docker in production right now? 3.5. Okay, that's actually about what we see. And so this is the title of the talk, Thinking in Containers, Using Docker to Build Something on Azure. I actually joined Microsoft. I'm a repeat offender at Microsoft as a full-time FTE. But I joined the team in the Azure Linux compute team about 4 or 5 months ago now. And I came back because I was super excited about how hungry and what the appetite was for going after some of these bigger open source and Linux-based investments. And it was really, really super cool to see Satya get up on stage and say Microsoft loves Linux, which 3 or 4 years ago nobody would have even thought to think about, honestly. So one of the things I've been working on quite a bit since joining the team is taking a look at what the container landscape is, what some of the things are out there around containers, how people are actually using them, what the supporting orchestration tools are, and things like that. And it's a super interesting space, super, super fast growing, and hopefully we'll cover a bunch of it today. So here's the required slide. I don't know, have you guys been able to actually scan the QR codes during the sessions? Cool. I haven't tried one yet. So here was the agenda for today's session. So I was going to take about 10, maybe 12 minutes up front to talk about just Docker and the overall container promise. That may stretch out a little bit, given that some of the 40 minutes on the back half of the demo went down this morning. But we still have some really cool architectural stuff to talk about, and I think it actually will open up the floor for a little more interaction between you guys and myself. So the first thing I want to talk today is about Docker and the general container promise around it. And we'll start off with this joke and say for developers around the world, developers like yourselves and myself, DevOps has always been a whale of a problem. I think you can probably see where this is going. So here's my favorite depiction of DevOps actually in the world. And you see a bunch of starving developers there trying to tame the beast and really having a difficult time with it. This is, of course, Moby Dick. But in more popular culture, the whale has continued to be a symbol of DevOps excellence. And that's the fail whale. So I don't know how many of you guys were on Twitter when the fail whale was popular. I remember seeing it quite a bunch, and it was really symbolic, actually, of a company that was growing super quickly. Really liked the idea of moving quickly, picking up a bunch of new users, but not having the engineering process kind of in place to catch up with that growth. I can't say that anybody would have had the structure in place to do that because Twitter was so fast and growing. But this is something that kind of stuck with us. And so the reality is everyone in here knows is that when we get into production, no matter how well it worked on my personal box, when we get into production, VMs blow up. Things go wrong, networks go down, things like your demo machine don't boot up, and it's just part of being a developer. And what we've gotten used to, and maybe it's because we're just these type of folks that can kind of work through some of this stuff, but it's really okay. I mean, that's just a reality of life. There's failure built into the system. You're never going to build a completely bug-free system. We joked at my startup actually that we spent about 90% of the time fixing bugs and the other 10% of the time writing more. But That was actually one of our highest efficiency points, actually. But it's OK, right? And so if we kind of buy into the hypothesis that we can, in fact, build better systems without sort of that DevOps expertise, Docker becomes a really interesting thing to talk about. And so to complete our whale metaphor, the newest whale on the block is this guy who you've all seen. And this time, though, what Docker's trying to do is really make the whale a symbol for good, particularly from the perspective of the individual developer. So over the last 2 years, I've been looking at open source software for a number of years now. I've been involved in the startup space to quite a degree. And I don't know if I can ever remember a startup that's really taken off, particularly on sort of the core, really battle-tested infrastructure side of things than Docker has. The last 2 years have been ridiculous. Super successful. Microsoft has a really public and great relationship with Docker. One of the engineers on my team, I think, was actually the top contributor to the Docker open source project over the last 3 or 4 months. And it's a super great product. At the same time, it's really amazing to me that was something that wasn't really more than an OS construct kind of hidden down in the Linux kernel a couple of years ago has turned so many of us in this room and so many of the enterprises that we talk to and so many of the individual developers and startups we talk to into Docker believers. And it's a really cool story. So when I talk to customers for the first time, we tend to get a lot of folks who come in and say, like, hey, I've heard about this buzzword. Like, what's Docker? What are these containers? And we find a lot of the time people have a really easy time understanding and sort of grokking the top-level benefits of containers, right? You get the portability story. You have community-driven stuff, so you don't have to go reinvent the wheel every time. You have potential cost savings at really high scale with sort of bin packing and better utilization of things. They get that part, but the challenge that we see from people going from individual sort of understanding of what the container benefits are, the barrier they face in making the jump into production is really sort of wrapping their head around getting out of this traditional VM model where we kind of just stuff everything in a single box. And so the really cool thing about Docker that I always try to land as a takeaway is that it helps us build better applications by letting us think in smaller parts. The old way of thinking is basically we treat the application itself, all of the components of the application, as a big single box. And so at least when I was starting to build applications, I would start with a virtual machine, some fixed amount of resources, some static IP address, one box. I'd have something called an application that was made out of one or more components, pack it all in there, get everything to work, have some sort of conditions and checking to make sure processes didn't go down and resources weren't being overutilized. And you know what? For the most part, it was OK. The problem is that when that system goes down, you, A, have a single point of failure. And when your traffic goes up or your service is more popular, it really turns into a very quick curse, right? It's a blessing and a curse to have a lot of attention from customers. And so what do we do in that case? Well, traditionally, we've been given two high-level options, right? We can scale up, which basically means we go out and buy a bigger box and still keep sort of the advantages of packing everything into that known model, but still having the disadvantages of having that single point of failure. Or we can scale out. And the prevailing opinion from folks I've been talking to, at least over the last 18 months and 2 years while Docker's been coming up, is scaling out really appears to be sort of the right way of doing things, or at least the popular opinion for the way to do things right now. Scaling up's worked a lot of times, and for very specific applications, it's absolutely the way to go. If you can live on one box and you are just doing crazy intense compute stuff, super compute kind of stuff, and you can pack 7 gazillion cores on the box, that can be a really viable thing for you. Same thing, any Bitcoin miners out there? You can get a lot of Bitcoin out of a Godzilla series on Azure, actually. And so there's applications where that makes sense, but scaling out is really interesting. The question is, like, what does it actually mean to scale out? And a very naive approach at the top level is, well, I just take the existing model that I have and I multiply it out across some more resources. And so in this case, we actually have 3 times the number of VMs and what I'm calling NX DevOps complexity addition. That N is different from everybody. For me, it's about 17, I would say. But I really prefer being in my editor writing code rather than making sure that the boxes are staying up. And so when you start digging into this sort of first level strategy for scaling out, you notice like, well, let's start taking a look at what my application actually needs. And instead of looking at it as a single black box, it's actually made up of several different containers. And those containers might be equivalently the same size. You might have one guy that's CPU bound and another guy that's IO bound and things like that. But let's just for the sake of the discussion say that we have things that are different, just different functional units, right? And so if I look at the scaling out, and my main goal in scaling out was to go and support the API that I wrote that's getting a ton of a ton of traffic and a ton of growth, I actually just sort of, not on purpose necessarily, scaled out and put 3 times the resources and all the extra manpower and complexity of worrying about keeping the other 2 web servers up as well. When maybe the web server for my kind of business is really cool for just launching my marketing site, but the API is really where I want to grow and perform. And so when we start looking at it at a more granular level inside of the box, just scaling out VMs is not necessarily the right way to go. So there's our favorite whale again, and this is where the Docker guys have really made a name for themselves stepping in. And so when we look at the Docker end-to-end process at a high level, the first kind of thing that we talk about is images. And images is really you hear a lot of buzz around containers, but images are really what powers containers, right? They're starting point. Think of them as a class or a frozen starting point for you to instantiate containers from. So in this case, we're saying that we have a sort of a web starting image and an API starting image. And from that, through the Docker CLI tools, we can actually go take that template for containers and spin up an arbitrary amount. And what's really cool about containers is that you've already got everything you need for that very specific function ready to go in the image. And the boot time is super fast. So if you've ever actually played with Docker, how many folks have actually spun up a Docker container in here and kind of gone through that? Oh, very nice. OK, cool. I guess that makes sense in this talk. And once you've spun up the containers, there's this whole question of, OK, cool, I have these really super light, fast, portable instruments here. How do I get them onto the VMs and the infrastructure that I'm sort of more familiar with? And that's really, of sort of the 3 steps, that's really the big open question right now and where we're seeing a lot of really exciting stuff going on. Generally, we refer to that as sort of the orchestration family of considerations. And that's basically like if I have a workload that's comprised of an arbitrary number of components, how do I go and stick it out onto an arbitrary number of boxes in the way that makes most sense for my application and my resources and the financials and things like that? And so just to sort of finish up our sort of leveling the playing field for folks, I like to think of containers as lightweight VMs. Small footprint, really fast boot time. They have a shared kernel, right, which is fundamentally different from how our traditional virtualization in VMs works, where the guest OS basically takes over the kernel and the resources from the host. And so containerized apps today run anywhere that Linux can. So I think all of the 5 or 6 officially supported distros of Linux on Azure currently run containers today. You guys have heard a little bit about the fact, I'm sure, that Windows is coming out with containers, and I think Taylor's in here. Taylor, have you had your talk yet? Oh, sweet. OK, cool. Well, you guys will hear a lot more about it then. But very soon in Windows. So we covered this a little bit already. I like to think of images being frozen environments, and they're the things where we actually create the containers. The other cool element that we talk a lot about with people is sort of what I call the NPM phenomenon, where Node.js was this thing that sort of like legitimized this language that a lot of people thought had died, right? And was just sort of this kiddie scripting language. A lot of the success for Node was obviously, there's some advantages, and people like some of the asynchronous programming model, but a lot of the actual success can be attributed to just how the community kind of shaped up around it. And while Docker didn't necessarily invent a new operating system construct, it's not like they invented this idea of containerization and virtualization. What they've been really successful at doing is providing the right layer of abstraction for folks like us who don't want to go down and make those direct system calls and interacting with the kernel constructs, and give us just enough abstraction away from that where it's like, hey, I think this is actually reasonable for me to start playing with. The other side of that is they've had just tremendous adoption by the community and folks like you guys. So if you ever take a spin around Docker Hub, there's, I don't even know how many at this point, but hundreds, maybe thousands of containers up there, images up there to start your containers from. And that's really impressive, and one of the reasons why, when we take a look at Docker's relationship with Microsoft, why we're so excited to be working with them, because we see this really, really dedicated sort of community support around it. So last slide on this, the container promise overall, fast, portable, more resilient apps, scale through components and not just by multiplying the number of VMs I have at my disposal. And so this was the part where we were going to start building something. And I gave you guys kind of a caveat before that we're not going to be able to get through quite the whole thing, but hopefully we can still stand up one or two things. So, how many of you guys have ever heard of Azure News before? Nobody? Oh, that's because we're going to build it right now, and I made it up this morning. So what we're going to try to do is actually build essentially the functionality, or think about how we would be building the functionality of the new page on Hacker News. How many folks in here are familiar with this site? Probably. Oh wow, that's actually a little lower than I thought. But for those of you who don't know, this is sort of the startup and open source haven. It's essentially a news blog that's sponsored by Y Combinator, who's an incubator down here. Lots of people go up there. Very, very simple in terms of functionality, but tons and tons of users. And they're actually kind of famous for having written in some sort of article once that even with the amount of traffic that they get, which is astronomical a day, they are running the whole thing on one server, which is really interesting. And so when we're kind of dreaming up like what we might want to do today, here's the 10-second spec of sort of Azure News and what that's going to look like from a product perspective. So Azure News is going to be basically like the front page filter of Hacker News. We'll show the 30 most recent posts, and in this case, because I'm not going to be able to generate all those posts myself, one of the elements we're going to try to bring in here is an API server dedicated to handling the SMS requests from you guys. We have a simple MongoDB setup, which we will also containerize on the back end for persisting the stories or posts. We had a local cache of stories, and that was really the big thing that went down. I had Redis all set up, and just I cannot figure out some of the cert issues after moving it across a couple different environments. But hopefully we can work around some of that stuff. And no comments are upvoting today because we've got a relatively short amount of time. But I will be posting all of this stuff in GitHub, and so if anybody's like really interested in this for some reason, I'd be happy to kind of keep banging on it a little bit. So here's the first sort of what we would call the sort of old school approach in the Docker world. We do have the option of doing exactly what the folks at Y Combinator have done, right? There's actually a lot of just really practical, pragmatic benefits to this approach. A, we're familiar with the model. B, when everybody's on the same box and you take away a lot of the networking constraints and difficulties around coordinating those distributed elements of things, you get a lot more reliable experience. There's a million proof points out here. If you go and look at sort of like a canonical Rails app and all the tutorials you can find when you type Rails into Google or Bing, you can see something like this, right? People aren't thinking about scale out of the box in a lot of those tutorials, and you can absolutely get something to work like this. This diagram was drawn in a very specific way, such that we could take a look at the actual functional atomic units of the application and see how those map back to a container. And in this case, what I'm proposing is that we actually break the application out into 4 separate containers, each with its own functional purpose, and each of which we can scale in sort of an atomic and independent fashion of the rest of the application. And that gives us the advantage of avoiding what we looked at before, where just because I needed to scale out one particular element of my application, it doesn't mean I have to go out and pay X time the resources for everything else. And so the way that this really simple example kind of looks like from an architectural standpoint is we have over here on the right-hand side, we have the SMS container, SMS image, whatever we're going to call it there. That guy is essentially listening to you guys and taking in input. All that guy does is receive that input, do a little bit of processing on it, make sure that you guys aren't going to put us up onto different interesting websites up here during the show, and then write it out to the MongoDB database. From there, we have just a web server that's going to be sort of the server that just gives you the page and the results, and also a local cache paired up with that server. And I opted to have the cache here. We could have very easily just gone with 3 containers, but the cache thing is, from an architectural standpoint, is kind of interesting when you look at the container space in general. There are schools of thought. Actually, a lot of the Kubernetes project, if you guys are familiar with that, might break this up a little differently. And in particular, they might argue that you could actually stick the Redis cache and the web server in the same image and container. And that's because if you step back out a little bit and you don't go all the way back and see this big black box, if you step out a little bit, you can see that those are probably pretty tightly coupled, or at least in terms of their benefit to one another, they're pretty tightly coupled, right? If I break these out into separate containers when we start instantiating them, sure, I can go out and scale the caches independently of the web servers, but at some point that has very, very little return for me, right? Like if I have 85 Redis instances for one web server, there's not a ton of functional utility right there. So just because we can be a purist and really break them out into these atomic units, that doesn't mean that necessarily it's a hard and fast rule. So the Kubernetes sort of school of thought around pods, I think personally the way I interpret that would kind of take a look at this read cache area as a potential for grouping that. And that's just to demonstrate the fact that there's really no black and white here. The big goal is to get yourself into a position where you think you can have multiple failover points, multiple scale vectors, and a way of building out the application in a more distributed fashion. So with this high-level architecture, essentially what we get is this type of flexibility. So just to hop back, right? Basically, we can just blow out any single element of the application. And so in this case, we say, hey, well, if you need to, and we had a ton of records for some reason, or we started doing some data workloads and we wanted multiple copies of the data, we could blow those out horizontally. If we needed more SMS stuff because you guys thought it was so cool, we tweeted and got everybody else calling in, which I was contemplating sort of periscoping this thing and seeing how many people we could get banging on the server, but we'll see if we can actually get it to boot first. And then just demonstrating the general scalability on Redis and web in general. So the first thing that we're going to take a look at, and we'll hop over to the computer here, is MongoDB. So you guys let me know if I'm doing this right. So for those of you curious, this is actually my officially Microsoft-issued machine. So the times are a-changing, in fact. Yeah, thank you. Yeah, I like it a lot. It holds like open source stickers a lot better. So this is my second one that I'm going through here. Can you guys see that at all? Does anyone of the Mac clappers in the room, does anyone know when you're plugged into a 18K display how to get the Command plus on terminal? Woo! All right, I got something out of this talk. Fantastic. Okay, cool. So how many of you guys actually, when you're playing with Docker, how many of you guys actually are on a Linux box? Probably about 40%. Cool. Anybody use boot to Docker? Anybody been successful using boot to Docker? Okay. Cool. Yeah, I mean, boot to Docker, for those of you guys who don't know, is actually powered by VirtualBox, which is a free virtualization software. I actually think it's really handy. We actually use it internally to roll out the latest bits of our cross-plat CLI. So whenever we rev the version, somebody just sticks a new Docker image up on the repo, and so that means you guys can also go in and start banging on it as well. But it's just really, really convenient for doing really quick, spin-ups and teardowns of development environments. So what I'm doing here actually is that I've gone ahead and set up a couple of Docker hosts. And so all of the machines that we're going to be doing Docker operations on today are sitting in Azure. As part of the relationship with Docker, we've been trying to come up with as many creative ways as we can to help people get into a really solid Docker environment as easily as possible. One of those things is, do you guys use Bing just for the picture of the day? It's pretty good. So if you guys have checked out the new portal at all, and I know a lot of you guys, if you're Docker fans, or probably live more on the command line, but we do actually have the easiest way to get started with Docker on Azure is through a marketplace offering that we have. And we have two things that I'll just spend 2 seconds on kind of going over. So one of them is just an Ubuntu server that comes with Docker installed. So it's just a pre-canned Docker host coming out of the box. Nothing special. We open up the right ports, the Docker ports, and SSH to get you going. It just reduces 5 or 10 minutes of setup time. And so I tend to go to this when I need an experimental blocks and don't have access to my local boot to Docker solution. The other thing too is as part of the whole new CRP stack that you guys have been hearing about this week, and the new compute resource providers and other APIs here. We also have something called a Docker extension. And the Docker extension, just like any other extension that we have in Azure, is something that through those new templates and through our new APIs in general, you can pin onto a VM when it's coming up, and you just get whatever that small abstracted piece of functionality is for free, right? So we have a Chef extension. If you guys have existing Chef scripts, you just want to stick it in and pass it off. That just gets seamlessly handled for you guys. So we have a similar sort of thing to get you up and running on Docker as well. But given that we already have some boxes up in Azure, let's just make sure that we. So how many of you guys have played with Docker Machine? A couple folks? Okay, so Docker Machine is actually part of a three-pronged approach by Docker to kind of provide this whole really cool solution for orchestration. And Docker Machine's job is to just get you boxes in the cloud that are Docker hosts, right? They have support for a bunch of different clouds, local development environments even. But the idea is to just give you sort of that initial topology to start playing around with Docker. The next element of that is Swarm. And what Swarm does is basically acts as a logical load balancer in some ways, right? So if you have 5 or 6 different Docker hosts sitting behind or as part of a swarm, the Docker client will interact with that entire 5 or 6 machines as if it were a single box. And so that gives somebody an opportunity to essentially plug into Swarm and say, okay, so what are the rules that make most sense for me in terms of distributing where those workloads go when I put it out into the box? And the final piece is compose, which we'll take a quick look at today, but that's a way of saying, hey, if my app is made up of several of these containers, what are the relationships and dependencies between those guys? What ports do I need to open? And just give me sort of a definitive template that I can put it in, super simple YAML, and deploy it directly as a single sort of application thing. Not dissimilar to resource groups and that whole concept, actually. So a couple of quick commands just again, for folks that haven't been around. So right now, there's a cool trick where the Docker client, if you're on a Linux box, you can obviously manage containers that are locally on your box. If you're on a Mac box, there's tools like boot to Docker, which make you think that you're managing containers on your box, but there's actually a Linux box underneath. And then what we like to do a lot is actually spin up Docker hosts in the cloud and use these Docker machine environments to point us to different individual things at a time. So right now, I'm pointing at th-docker1, and that is just hanging out in West US on Azure right now. So let's see what we've got up. I apologize. Oh, that's a really good starting point. So we were jumping around with a bunch of these things dying off. But so if we take a look at MongoDB really quick, so MongoDB is one of the most popular images actually on Docker Hub. There's a really cool company called Tudum that is interested in that orchestration space as well. If you guys have a chance and are generally interested in Docker, I would advise checking them out. I think they have some really slick UI for defining applications that are container-based. Anyway, so this is an example of some of the community stuff that we were talking about before. Looks like this has something like 10,000 downloads on it. We have a chance to take a look at different versions and some help stuff. It's very similar to NPM. But when we start working with it, actually, the first thing that we need to do is to get the base image on the box. And so to get that, we have a command called, well, we can actually do Docker search for MongoDB. And while that's lighting up, we can actually do Docker pull for Tudum MongoDB. And then we'll remember that we're not pointing at the remote server. Let's see if these guys went back. So here are the results for all the MongoDB options that are there. We can get on the box simply by doing a Docker pull. That's going to download it to the box and then give me a platform essentially to start off with. I already have it pre-cached on the box because I've been playing with it a couple of days. And the best way to get started with it is with Docker Run. So Docker Run gives you a couple of different options that at a high level give you basically the decision as to whether you want this to be a long-running, long-term behind-the-scenes process or something that you're currently interacting with and is perhaps more short-lived. So because Mongo is going to stand up and be a long-running process for us as sort of our main database in this case, we will deploy it here. And so for people that aren't super familiar with Docker's command line, so we're doing Docker run. The name is a way to tag our resources. If you leave out the name, they'll come up with like a crazy adjective and a crazy noun, and they're really hard to type when you're trying to manage them. The D flag tells us that it's actually going to run as a daemon, and so it'll be in a background process where we're not going to be looking at its output and logs directly. And then this is probably one of the most interesting things in the space around containers right now is how you get containers to talk to things that are outside of containers, and specifically talk to containers that aren't on the same box as you. And so one basic primitive that Docker ships with out of the box is the ability to take a port that's on the container and map it to a port that's on the host. So you can essentially open up ports and give yourself endpoints so that if I'm trying to stand up a web server that's running on port 8080 internally, I need to also expose that. I need to basically pipe that through to the host so I can get traffic in and out. And so you just kick it on. So we're able to kick it off, and from scratch to start, right? That was about like 3 seconds, even on a shaky kind of internet connection here, to actually make the request efficiently. That's how quickly we're talking about when we look at really fast boot and super small footprint. So that's a full like MongoDB server spinning up and ready to go right there in 2 or 3 seconds. And for those folks that have done the process of installing it yourself on your local box on either Linux or OS X, it's certainly not that quick. And the big takeaway there is that, like, hey, in the big scheme of things, there's not going to be 3 seconds that kind of make or break deployment necessarily, but it's just a testament to sort of the flexibility. If you had to spend multiple hours getting a database set up when you could get a container spun up with similar type of functionality to go kick the tires on it, that's actually really cool in terms of getting people to get started on trying new technologies. And I think it's a really great part of Docker. So we kicked off the Docker, the MongoDB container, and so we can check out what's running currently on the box by doing Docker PS. So it's just essentially the processes that are being managed by Docker. You can see that it pulled from the latest download that we had for MongoDB from Tudum. It's been up for about a minute. One of the things that you can specify when you're building a Docker image is the command that gets run when your container actually starts up. And so that can be any sort of arbitrary script. It can be any executable that's already on the box or that you had installed as part of the image. And so it gives you the flexibility basically to do whatever you want there. I'm not sure, I've never tried to do this before, but Docker has a function called Docker exec, which allows us to basically jump inside a running container, even if they're running as a daemon in the background. And so that can be really helpful when you're trying to debug and figure out what's wrong, because the thing's not sort of front and center when it's displaying the logs. -ti. And then we'll db and bin bash. And now I'm sitting in the MongoDB container, so I can go in and peek at logs or whatever I'd like to do there. So that's a really cool thing where even if you've got a bunch of these containers spinning out, they're never really like out of touch. It's not like you kick it off and you can't get back into them, which is sort of a misconception we hear a lot when people are starting with it. So anyway, right now we've got a MongoDB instance up, and to prove that's up for you guys, we have, you saw that we opened up 2 different ports, I think 2717 and 2817. And so this is the default beautiful management portal that ships with MongoDB these days. So you'll see at this point, because it's brand new, we actually have no databases in there. It's just sort of the standard admin account holder. It's just a clean box that is fresh from boot. So we've got that up, and that's the first part of the application. Let's see. So the second part of the application is actually getting a little more into the details around what it takes to create your own image. And so in MongoDB's case, we started, somebody had done the hard work for us, right? They took some stripped down version of Ubuntu or whatever the base image is, did all the configuration, got it into a really nice, like, secure default configuration, and we were just able to go leverage that as sort of an open source offering. When you want to start getting into more complex deployments, though, it becomes really important that you feel you get comfortable with building your own images that you can start containers from. And the way that Docker is exposed to do that is through something called a Docker file. At a very high level, Docker files are basically just a really restricted set of commands that you can think of as applying layers and operations onto an image you start with. So when you guys hear things like CoreOS and Ubuntu Snappy and things like that, those guys are trying to be like the most basic image they can be. It's like the most stripped down version of Linux that's still reasonably safe and performant and things like that. And basically what they're trying to do is give you as close to a blank canvas as you can get for applying your own custom things onto that image. That's really cool. If folks that are out there who are Ubuntu fans, I've been using Ubuntu for years. Was not a huge fan of the fact that, you know, as they became more modern, right, we started having things like adware and stuff like that shipping in there. And when you're looking at doing things like fast DevOps deployments and consistent environments, you want to start from scratch as much as you possibly can. And so to take a look at how that works, you guys know the command for Emacs? Is that going to do the same thing for me? Switch screen. Yeah. Are you guys, I'm not even sure how to set this up. Okay, well, so from what you can see, actually, I'll do just a really quick navigation through it. We always start with a from statement when you're building your own image. So that's typically taking a really basic thing, or maybe a really basic thing plus one core piece of your infrastructure that you're looking to do. So in this case, I was looking to stand up a basic Express node web server. And so I just started from the base node image that's most popular on Docker Hub, right? So it's Ubuntu plus, you know, the bare installation of Node, and that's it. From there, Docker provides some really basic operations that you can do. They have this add functionality, a copy functionality. You can change working directories. You can copy things in. You can run arbitrary scripts. And then at the end, once you've got everything kind of set up, you'll see here that I copied in my package.json, defining the npm server, and then run npm install to get all the dependencies in there. And then the last thing you do is you have an option of doing this thing called an entry point or CMD, which allows you to run an arbitrary script when it's up there. You can always override that by passing in some sort of command on the command line when you're starting up the container. But by default, like I know this is my web server, got it configured exactly the way I want. I've got all the files in there, and so I just want this to start up exactly the same way every time without me having to do anything else. And in this case, you're just spinning up the server. And so based on that file, what we can do is what's called the Docker build. And so I'm in the container right now, or I'm in the directory right now. And to do a Docker build, it's just Docker build. We have a -t for a tag. And so in this case, I'll just call it web. And then the Docker file is sitting right here in this directory. And so we'll kick that off. So basically what it's doing, Docker tries to be really, because people almost never get their Docker images right the first time, I think I've rebuilt this probably 10 or 20 times. They try to be really smart in terms of making life efficient for you guys. So they do a bunch of caching when they bring down images. If you already have the base Ubuntu image on the box, they'll do that. They're very smart about doing sort of iterative file and layering on top of the image to get it built as quickly as possible. But in general, you know, for this kind of thing, I'm copying over some files. I'm doing it remotely, so I'm kind of sending up a build context into the cloud. It might take a couple minutes, but certainly extremely quick relative to a full-powered, full-size VHD, for instance. And then the last thing that we were going to show today was was Docker Compose. And Docker Compose was what we were talking about before, where it's sort of the third piece of Docker's overall orchestration strategy, and it lets you create a YAML file, which is sort of a nice man's JSON, I guess. and define your application and the dependencies and the relationships between containers in your application, and let you deploy it very similarly to how we've been talking about resource groups this week with Azure. And so this is where, in the process today, the stuff started to break down for me. But if we take a look at what we have here, so I've created another sort of working folder for my SMS server. Took a similar approach. Actually, if we look at the Docker file really quickly, it's very similar towards the first server that I made. A couple different file differences and a couple of things I want to do in terms of configuration, but very, very straightforward. It's really easy to work with the Docker files and get a super repeatable thing to work with. And then if we kick this off, we should. Sorry, I didn't set the context again. It's another great reason for actually passing in the name variables on your containers, because it's a lot easier to work with three-letter names that you can remember, in my opinion at least. While that's deleting here, you can take a look at, there's a new feature in here that we haven't talked about before, which is this link thing. And link does some magic stuff, similar to the way like Rails behind the scenes will light up a lot of cool stuff for you if you just kind of follow the rules. Link does the same thing for Docker containers, particularly on the same host. So if you define a link between a web server and a data workload or a database, something like that, they'll basically have a really shorthand way of communicating with each other in the code. So in this case, we are linking the SMS server with the database it's got to write to. And so instead of me having to have like an IP address that's hard-coded in the thing, I can just refer to the name of the database and be able to have a connection string to it, essentially. So this is kicking off, and while this is kicking off, since we had an error on the cache in the front end here, this is our new. This is going to be our new Hacker News right here. It's command line news apparently. And if everything is working right now, what's happening behind the scenes is we actually have two Docker hosts. We have one container that's running the SMS server, which is sitting there waiting for you guys to text it. And we have one server that is, one container that is running the MongoDB workload. Those guys are linked with the shorthand, so they don't even have to know about where each other are. They don't have to do any sort of discovery. They can just reference each other directly via the link. And when the server receives new SMS messages, it's going to dump it into that database. And we're just missing sort of the end display there. But I believe if someone wants to do a little beta for me here, we can send a text to this number. And just be careful, because my messaging rates do apply in this case. This is a thing on Twilio I set up. If anybody's ever worked with Twilio before, it's fantastic. So somebody sends, I just got one from Milwaukee. Well, who's here from Las Vegas? Oh, very nice. What are you doing here instead of Las Vegas? We'll kick it back over so you guys can see these coming in. And so this is a Docker 2-container sort of workload working in production. In real time, you guys are sending us text. We're parsing that, getting it, sticking it back up in a MongoDB database. It's up there, really super solid. What's cool about it is that I don't have to take the whole system offline, right? So if I wanted to make a change to the output that was going to be made on receiving the text right here, I can leave the database container up independently. If it's multiple containers, I can take down one of the SMS servers and update that while you get sort of this upgrade and failover zone functionality. And they're able to work and scale independently of each other in that case. So I apologize for not getting to the point where we had the really cool like Hacker News clone up there, but you guys can at least see that the data is being piped through, container backed, and it's actually really, really simple to set up, leveraging some of the constructs Docker gives you. Also, thanks for participating. That's awesome. So to kind of wrap up some of the back side of this here. So Docker is really, really cool, at least in my opinion. I get to work on it all the time. We're on a team that contributes directly to Docker. I think are the Docker guys here in the room? They're at least upstairs, and they've got some cool stickers and swag for you guys too. But if you actually take a look at the people in this space right now, there's some really, really interesting players in the space. Docker obviously is at the front and center of those guys, but one of the folks that we announced a relationship with yesterday actually are the Mesosphere guys. And Mesosphere is a super cool company that's taking a look at, well, if I have a bunch, it's like thousands of nodes, hundreds and thousands of compute nodes, how do I make sense of deploying my workloads onto those? And I should be able to treat all of those things as a single compute resource. It's similar to the way that Swarm's approaching sort of the Swarm and Compose scenario. And I should be able to put really cool constraints and not have to worry about the DevOps side of things. I should get the monitoring and the ability to spin those things back up against a predefined definition that I have for my expected SLA and uptime. Cluster HQ is also really cool, and you guys should check them out if you've been thinking at all about working on Docker in production. So we're currently starting to work with them to help bring their storage driver onto Azure as well. But these guys are doing some really cool stuff in solving one of the really hard problems of containerization, which is handling stateful workloads and data that you can't afford to lose. So containers, just by their natural characteristics, fantastic for things like burst workloads and things like that. If you don't care about the data and you can lose a couple of the things, the ability to spin up a gazillion of them super, super quickly is really attractive. But as soon as you have business critical information and databases and things that need to stay in particular regions and things like that, without a proper orchestration story and mechanisms for maintaining that security and stability and resiliency, really, it's really hard to convince some people to go into production with containers. Cluster HQ has a product called Flocker that's really in the early beta stages, but is really, really cool and promising. So I'd go recommend checking them out as well if you're interested in that. Essentially, I have this really cool feature where I can actually move my database containers around, and within the database network that it knows about, it will essentially act as sort of like a DNS proxy for you and handle all the rerouting, so you never have to do self-discovery. So you can move boxes safely, seamlessly, scale up, and things like that, and it's really neat. And containers are really just the start. We're, as a company, as a developer myself, we're really excited to see where the container space is going. I'm seeing more, every event we speak at, we're seeing more and more people that have actually made the jump from sort of the standard VM approach to actually going after containers, trying to put it in production, working with more and more startups that are running like beta versions of things like CoreOS and alpha versions of things like CoreOS, specifically to take advantage of really the bleeding edge features that Docker is offering. And so to wrap up really quickly, I will be posting, once we get this working, the code for the full Hacker News clone up on this site. If you guys are interested in just like how you interact with Twilio, which is what powered some of the SMS stuff there, it's cool. You can check out, if you've never really played with Docker files before, or even some of the basic features around Docker Compose and defining those relationships and links, that stuff will all be up there. So here's an obligatory slide. Please check out any of this training if it's interesting to you guys. And with that, I think we've got like 4 or 5 minutes left for open questions, or for you guys to keep texting me. Anybody still texting? We got a pretty cool sample. I'll throw it up on Instagram later. Thanks, guys.